Okay, is this the first thing you guys have on your sheet? I think so, right? Charles, when you brake a car, now I'm not talking about braking as in like busting it, okay? It's actually spelled different. Brake a car. There are two distances that are relevant. Number one is what's called the reaction distance.
Oh, we got it right.
Yeah. Reaction distance. So what do you think that means? That is it's a distance. It's the distance traveled and the time it takes to get your foot to the brakes. The distance traveled in the time it takes to get your foot to the brakes. Because we are not supermen or superwomen. It takes time for our foot to go from gas to brake. It takes time for our minds to react. It is the distance traveled and the time it takes to get your foot to the brakes. The car is traveling at a constant speed. How come? Why is the car traveling at a constant speed during this reaction distance? You haven't got your foot to the brake yet. If you're doing 100, your foot's on the gas, right? You don't stop being 100 until you get your foot to the brake. Now, having said that, I realize I've been driving a long time. When you take your foot off the gas, what happens? It immediately starts to slow down, right? Okay, so that's, I mean, we are simplifying it a bit, but you don't actually begin braking, right? Now, having said that as well, if you're on cruise control, when do you start slowing down?
When you hit.
Now it's not until you get to the brake, right? So there's a difference there. I'll tell you a story there. I was coming home Friday night. We saw 3 deer just past Oak River there. I hit the brakes pretty hard. And those stupid deer, of course, kept on coming, kind of thing, right? But I was able to sort of brake, and I was sure glad that the road was dry. I had good tires, and then I was awake and paying attention. Okay, so there's that reaction distance. Then, what's the second distance? The second distance is the braking distance. This is the actual distance traveled while actually coming to a stop. The car is now slowing down or decelerating. Right? Braking distance. So there are two distances. Is that making sense? Yeah. Here it is in pictures. I think you have the label.
I like how funny that sounds.
Okay, so we got the reaction distance and we got the braking distance. Now you'll notice here that the car is, right, evenly spaced, but here it's actually slowing down. They're getting close together, right? All right. Okay, so how do we calculate reaction distance? How do we calculate reaction distance? So since you're traveling at a constant speed, we're going to use the formula D equals V times T to find the reaction distance, okay? Because we are traveling at a constant speed. Displacement, or distance, is the speed multiplied by the time. Let me show you an example. Suppose we got a car traveling at 60 kilometers per hour, and the person's reaction time is 0.3 seconds. Do you think that's a reasonable reaction time, 0.3 seconds? Right? That's the time it takes for your brain to register when you need to stop and get your foot on the brake. 0.3 seconds. 60 kilometers an hour. Now, how do we get to meters per second? Have I showed you this yet? No? Okay. So here's the rule. To get from kilometers per hour to meters per second, you're going to divide by the magic number 3.6. The magic number 3.6. Where does 3.6 come from? What makes it so magic? Are you interested? Do you care?
Yeah.
How many seconds in a minute? How many minutes in an hour? 60 times 60. Can you do it in your head? 6 times 6 is? 36, and then 2 more zeros. 3,600.
Oh, wait, okay.
Pretty smart guy, eh? Okay, how many kilometers, how many meters in a kilometer? Well, there's 1,000. So when you take 3,600 divided by 1,000, you get the magic number of 3.6. So you always thought the answer was 42, Chloe, but it's 3.6. Finish the book?
Yeah.
Yeah.
Long time.
Mm.
And I'm really sad because
Oh, this, there we go.
All right, so we've now got our speed in meters per second. So what am I going to do? I'm going to multiply by the time. So I'm going to take that 16.7 and I'm going to take 16.7 and I'm going to multiply by 0.3. Where does the 0.3 come from? Reaction time. And I get 5.01 meters, and I have no idea why this says that number. So I'm going to delete that.
Equal to,
So there's our answer, 5.01. That's just what? 5 meters to stop? That's just the reaction distance. You're traveling at 60 kilometers an hour, and some people do that down Main Street or down Mountain Road or River,
60 miles.
and your reaction time is 0.3 seconds, which you all agreed was pretty reasonable. Right? 0.3 seconds is a lot of time. 5 meters is like 1, 2, 3, 4, 5. That's how far you go before you even stop. Sorry, that's how far you go before you even start to begin to stop. Kind of scary.
so like if that all was like a truck or something.
Yeah.
And then
You still hit the
Where did I start from? From here?
yeah, and then you start braking, and by the time you actually started braking, you would have-
I'd be here before I actually got my foot on the brake. What are the chances that I'm going to be able to stop?
None. You'll probably try it, but it's not gonna
I tried swerving.
Even if I knock that down, Chloe, even if I knock that reaction time down to 0.1, that's still going to be almost 2 meters, right? Okay, let's keep going here. You guys probably have no, don't have to turn the page yet. So the next step is to calculate the braking distance, right? Okay, so I'm going to give you a new formula. Since you're now slowing down or decelerating, we're going to use this formula to calculate the braking distance. So the formula that you're going to use is, Ruben, you should put your phone away and pay attention. Oh, okay, sorry, man. D equals V squared over divided by 13.8. Okay, now that 13.8 is sort of an average figure for an average kind of car. Okay? Cars that have good brakes are going to be able to stop faster. Cars that have lousy brakes, much less. So that's just kind of the number we're going to use in here, because otherwise it's all over the place, right? This assumes a braking acceleration of 6.9 meters per second squared, which is kind of an average speed, or average acceleration. So V squared divided by 13.8. Okay, so again, we're going 60 kilometers an hour. I think you have to flip the page. Do you have to convert to meters per second? Yes. Is it going to be the same as the number before? Yeah, you don't need to convert again, right? So 60 kilometers an hour is 16 meters per second. Let's just pace that off. If you're doing 60, 16 meters per second. That's like 9. So this whole room is like 10. So like we're talking like my room plus Mr. Spagowski's room. That's how far you go in 1 second. Doing 60. 60 is not very fast. 1 second. That's pretty far, don't you think? Would you run all the way down the hallway
Try this.
with your eyes closed?
Oh yeah.
Maybe.
Let's do it.
Probably not, but yet people do it on the highway all the time. They don't close their eyes on purpose, but they take their eyes off the road to do what? Look at their phone?
Not me.
No, not you.
I don't do that.
Lost your driver's license already? Oh.
My phone is
16.7 meters per second. Okay, so the braking distance, here's how you do it. You're going to take the V squared divided by 13.8.
Yeah.
What's the V value? 16.7. You gotta square it, right? Not multiply by 2. Square. We're on page 2.
Page 2. Oh, this is page 2.
Still at the top of page 2,
Oh,
right?
there's only 2 questions.
So it's going to be 16.7 squared divided by 13.8. 16.7 squared is 278.89 divided by 13.8. Your braking distance is now 20.2. Am I done? No, I'm not done. What do I have to do? I got to add them together. This is the braking distance. This is the stopping distance, or the braking distance. You got to add that reaction distance. You got to add them together for a total of 25.21. 25 meters.
0.21.
Well, give or take a few centimeters. If you're doing 60 kilometers an hour, the average car will take 25 meters to stop. 25 meters is a long way. That's the length of that hallway. Hard to believe, really.
What speed do you get on that?
At 60, Charles. Right? 60. They always say, and you guys have taken driver's ed, right? They say that you really shouldn't be looking like at the road right in front of you. Where should you be looking? Yeah, down the road, right? You're looking for things that are right in front of you. You should have seen them already. Right? I was glad that I was kind of scanning the ditches looking for deers.
I do it all the time.
Okay. So here's another example. You guys have lots of space there. I would suggest you write down the steps. Should you have these steps on your cheat sheet for the test?
Yeah.
Oh yeah.
Okay, just.
I'll just leave it there. I'm going to do my attendance. Why don't you just write it down, Charles?
Well, it's just easier because then I'm like.
Okay, well, here's how to do it. Okay, so again, this is the example where you're traveling at 100. Not the one on the next page, the one where you're traveling at 100. Step 1, convert to meters per second. How do you do that? Divide by 3.6. That's step 1. If you're doing 100 kilometers an hour, you're traveling at 27.8 meters per second. Almost 30 meters. What's the next step? You just wrote it down. What's the next step, Charles? Look on your phone that you just took a picture of. What's the next step? How do we calculate reaction distance? What formula do we use? D equals V times T.
Yeah.
Right? So what speed are we talking about? 27.8. What's the reaction time? 0.4. They're not as alert. 11.12 meters is the reaction distance there.
0.4.
0.4, that was given in the question, right?
Okay.
See it in the question there?
Yeah. Thank you.
Yeah? Okay, so what's that? That's just the reaction distance. How far you go before your foot gets to the brake.
Now you have to go calculate braking distance.
Now the braking distance. What formula do we use?
The D
equals V squared over 13.8.
Yep. Okay, so
Right? So you use the 27.8, make sure you square, divide by 13.8, and you get 56 meters. "56 meters to stop when you bring against the brake, doing 100 kilometers an hour."
okay, now you gotta add something
Now you got to do what?
to add.
Add those two distances together.
So the 11.
11.12, you add it together with the 56, and you get 67 meters. That's how far it takes you to stop if you're doing 100. 67 meters, that's pretty far.
So now what you guys
say hurrah, you're done.
Oh, that's it.
That's it.
So what was the
Look at the-
top number?
Let's go back and look at the steps, Charles. How many steps are there?
There's
There's 4 steps, and the last one is add the 2 distances together,
Oh, it's just text.
right? Got it, Tiffany?
Okay.
Okay, so you have how many to do there? I think the first one, don't I give you the steps? Holy, am I generous.
Good.
Right? Okay, so the first 2, I give you as the steps. The next 2, no steps. You got 4 to do. What do you need, Tiffany? Yeah. Do you need these too? Will these help you? Yeah. I might even have the answers for that. Let me see.
Computer one.
I'm gonna need a calculator.
You want to borrow my phone?
No, I got my old phone here I could use, but I like the calculator, kind of old school. Goes with my age. So I gotta convert that 110, divide by 3.6, and you get 30.6. Yeah, that's okay. Tiffany, did you get that? Okay, calculate the reaction distance using V times T. So the velocity, what do we use? We use this, 30.6, and our time is 0.3. Now on my calculator, I just leave that number and I just multiply it. But I guess for maybe here, I'll go 30.6 times 0.3, and I get 9.18. Right? And the braking distance now, oh, what did I just do? The braking distance now, I'm going to take that speed, which is 30.6, and I'm going to square it.
So why is there another square thing right there?
Square it right here.
Yeah.
Oh, yeah, there shouldn't be, should there?
Yeah, I kind of get confused.
Yeah.
The first one again.
Oh, maybe, yeah. That's probably what it's supposed to be, right? I think Brandon's right. I think it's supposed to be a V squared there, right? Yeah.
Okay.
Yeah. Divide by 13.8, and you should get, oh, I skipped a step here. I get 67.9.
Yeah. I got
Yeah?
67.
I think it's 67.
Because you're wrong.
I think it's 30.
30.6 squared is 936.36, and then I divide that by 13.8, and I get
Oh, I see.
67.9, right? And then you gotta add them together. 9.18, 67.9. 77.08.
Oh, I got 76.80.
That's fine. I take it. Okay, there's going to be some rounding differences. I'm not even going to say errors, rounding differences.
Yeah.
Did you get that, Tiffany? Awesome. Okay, try the next one. This time we're going 110. That's not very good. 30.6. Right? Calculate the reaction distance, so we're going to take that 30.6, and this person has a reaction time of, 0.6. That's not good. 18.36. And now the braking distance, V squared. So that's going to be that 30.6. 30.6 squared is 936.36. Divide that by 13.8, and you get 67.9. Add the two distances together. 18.76 plus 67.9. 86.66. And here's a little question for you. How much further do you think this is than a non-distracted time? This person's reaction time is 0.6. This person's reaction time is 0.3. Oh.
Okay.
Oh, now I get it. They're both 110, right? They're both 110, right? This one is 0.6. This one is 0.3. This one's 0.6. This one is the person is distracted. Maybe texting, watching Netflix, putting on makeup. 86.66 compared to
Yes.
77. So that's a distance of like 9 more meters.
What is that, 85?
9 meters. That's like the length of this room,
86.
right?
Around there?
Hang on, Timmy. Okay. I'm going to leave this up here. I'm going to stop talking. This is a formula sheet that you might want to jot down or take a picture or do what you need to, right? That's every formula that we've done up to now. And I think there's 2 more additional exercises that are due, right, where there's no steps.
Hold on.
Okay, so you should probably have that on your cheat sheet. You should try those 2 last breaking question ones as well.